You should have seen scale factors before, right? And so we're going to talk about that here. So I have a few highlighters ready if you have them. Okay. So scale diagrams, that's section 8.3 of this chapter. A scale diagram is a diagram, right? A drawing where measurements are proportionally reduced or enlarged by a constant factor. Page 21. Okay. Scale is the ratio of a measurement, right? Of the scale diagram corresponding to the measurements on the original or actual object. Okay. Scales can be reduced just like fractions. Different units are okay, but no decimals. That's one thing you want to make sure you understand. Okay. And this is the one, I'm going to use a different color for this. This is basically where most of the action is going to happen around the scale factor, which is denoted with the letter K. It is similar to scale, but it is expressed as a fraction, decimal, or percent. Okay. So here you will see the similarities and the differences between scale and scale factor. So if the question talks about pictures, blueprints, or models, or anything like that, I want you to use diagram and actual. Okay, so a scale is written like that with the colon in between, and the scale factor is more like an equation. So watch, K is equal to, and you have diagram on top, actual in the denominator. So the important thing is to identify in the question which one is which. Which number refers to the diagram, which number refers to the actual object in real life. Okay? If you're talking about making copies or replicas or something that's similar, okay, then we want to use new and original. And so the scale factor, the pattern stays the same. Watch, right? The left it goes on top, and original. And these are all going to be numbers down the road, by the way. One thing about scale factor, you want no units. That is important. No units. I forgot to highlight it up here. I say it one more time. But you can't say things too many times. I've got 2 kids. I tell them to turn off the lights in the basement 10 times every day. It's still not happening, right? So that's that. So we're going to use these a lot. So have them on your study sheet after today. Scale factor. We could reduce something or enlarge something, right? So it's either or. Remember that the scale factor affects the actual original, which results in the diagram or the new thing, right? So something happens to this to get that, okay? So when we look at the scale factor, it tells us what happened to the actual or the original. So let's imagine we have this car. If you have a scale factor that's less than 1, you will get a reduction. I will say under K is less than 1, I will also have K is less than 100%. Okay? So you have a reduction. So some examples is if you get K, which is 0.19, that's less than 1, obviously you know that the original will be reduced. Okay? You could have K is equal to 2/3, or K is equal to 65%. And I need you to understand, especially with percentages, if you have K is equal to 65%, that can also be written as a decimal, okay? So that you should understand. K is equal to 1 would also be 100%, okay? Before I move on, if you have your car, right, and the scale factor is 65%, let's say, how much has it been reduced by? It went from 100 to 65. It went down by 35%. Okay. So I will write that down. There's a 35% reduction. So sometimes students, when I say, hey, something has been reduced by 35%, they think K is 35, and that's not correct. K is reduced by 35%, so you got to take the 100, subtract the 35 to get that. If K is equal to 1, then there's no change. Obviously, you're talking about the original, nothing has changed. So I'm just going to leave it like that. If K is bigger than 1 or K is bigger than 100%, then you have an enlargement, right? So K is 1.2, let's say, which could also be 120%, okay? Anything like that. Or you could have K is 5/4. Those are all bigger than 1. If you have 120%, if the scale factor is 120%, it means that it has been enlarged by 20%, correct? So you went from 100 to 120. So that one is easier to see, but just remember that. What happened to 100%? Did it go down? Did it go up? All right. So knowing this, let's go and do some questions here. I used up a little bit too much time with that activity earlier, but that's okay. I think you were working, and then I'll make up for it later. So given the scale 1 centimeter to 50 meters, state the scale factor used in these 3 forms. Okay, so let's do that first. Our scale is 1 centimeter to 50 meters. Okay, that is okay to have different units. We're going to turn that into a scale factor. Remember, this number here goes up top, and the 50 meters goes at the bottom there. But there's something wrong with that. A scale factor should not have any units. So we're going to do some converting. Just like before, right? It's all connected. So what do you want to do? I'm going to convert my meters to centimeters. That's what I'm going to do. So 1 meter has 100 centimeters. I get to cancel out. Watch what happens, right? Cancel, 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 cancel. It's canceling all around. So that'd be 1 over 50 times 100. You can use your calculator, or you can just, whenever you multiply by 100, just add the zeros to your number, and then you're good to go. That is your fraction, right? Let's turn this into a decimal. So I'm going to go comma, and I think this one is a bit of a problem. This calculator gives you a problem in this case. Let's see. 1 divided by 5,000 is that. What is that? That's a scientific notation. I'll put that on the note here. 2e to the negative 4, I want you to know that, is the same thing as 2 times 10 to the negative 4. Does that ring a bell? Scientific notation? It really means that if the decimal starts off here, it will shift over 4 spots. 1, 2, 3, 4. That's where the decimal goes. And then you fill in the valleys with zeros. Okay? So that's what that really is. This is that. And if you don't like that, if you're going to forget, my trick is to just add something to this. So if you go plus 1, so if I go answer, so I just go plus 1, it turns it into this. And then you can see, right, that it's 0. It doesn't happen very often, so don't be too worried about that, but that's how I fixed that. And what would that be as a percentage? You just go 0.002 times 100. Anytime you multiply it by 100, I'll put an arrow here and remind you. Just multiply that by 100, you get your percentage. Okay, so that's that. Either one of these is fine. Don't be doing this every time. If I don't say anything, I would keep it there. Okay. B, by how much has the original been reduced? First of all, can you tell that it's a reduction? It's less than 1, less than 100%, right? So it's a reduction. So we just go 100% minus 0.2%. I like to state this as a percentage whenever I can. Okay, so that'll be 99.98%. It has been reduced by 99.98%. That's it. So another one. I'll finish. I'll just get this one done, or at least start it, and then that'll be it. So maybe I'll ask you to do page 20 after all, like that irregular room. So A, the scale used to produce the diagram. So watch this. There's a diagram there. There's the actual there. Okay. So determine the scale. So you want to pick any two. So let's see how you see inches here, this length. This one corresponds. This one goes with the length here. So all you have to do is grab the 14 inches and put the 25 feet on the other side. Boom, you're done. That's a scale. This is A. Different units are okay. What's the scale factor? That's when you want to use K. And use 14 inches, 25 feet. What's wrong with that? Units, right? It has units, you want to get rid of it. So it's up to you what you want to do. I'm going to go feet to inches. I'm going to turn the 1 foot to 12 inches. Watch what happens, right? Cancel all around. Perfect. 14 times 1 is 14. 25 times 12 is 300. This is another beauty of this course. I no longer require you to reduce a fraction. And the reason is because the calculator can do that for you. So it's pointless. And I'll just show you how to do it. You go 14 divided by 300. Then you press math and just select that first option, fraction. And then hit enter. It will reduce it for you. Oh, you can't even see that, sorry. 7 over 150. There you go. And I'm going to leave it there. I will see here, hold on. I will not assign more from this yet, so I'm just going to ask you to do page 20. So I'll write it down at the bottom here. Page 20 is that irregular room. It's a Reno question. That way you will be pros at doing that. And so we'll just continue this tomorrow.